Hi guys, and welcome to 13.1 part 2, writing complex half reactions in acidic solutions. Don't worry about the complex half reactions. Complex just means more than one step, so it's actually kind of fun, not hard at all. In acidic solutions, so anytime they're asking you to balance something, they talk about an acid, you do it this way. There's also in your textbook talking about balancing complex half reactions in basic solutions. It's not in the program of studies. I'm never going to give you a question like that. Don't even worry about it. I forbid you to read about it in your textbook. Today, all we're going to learn is how to write complex half reactions and balance them in acidic solutions. So let's take a look at what that entails. It's just basically 5 steps. The steps don't change. They're always the same. Unfortunately, you do have to memorize them, but they're kind of easy to memorize because it feels like it's the right thing to do. It's just a totally different way of balancing an equation. Good times, hey? So number 1, write the chemical formulas for the reactants and the products. Balance all atoms other than oxygen or hydrogen. So if there's a nitrogen or phosphorus, you have to balance those first. Step number 3, balance oxygens by adding water. You're going to balance hydrogens by adding the hydrate ion. And you're going to balance the charge on each side by adding electrons. That's all you could do, kiddos, is add electrons. You can't take away electrons. You can't take away positive things. You can only add electrons to make sure that the charge on the product side equals or is the same as the charge on the reactant side. Okay, let's take a look. Nitrous acid can be reduced in an acidic solution. So we're talking about a reduction half reaction, and it can be reduced in an acidic solution. This is telling us that it's happening in the acid, so of course we have to follow those 5 steps. So to form nitrogen monoxide gas. Awesome. So what we're going to do is we're going to write the chemical formulas for the reactants and the products. Here we have our acid, nitrous acid. And here we have our nitrogen monoxide gas. Step number 2, balance all atoms other than oxygen and hydrogen. 1 nitrogen here, 1 nitrogen here. We don't have to add any coefficients. This is the only time where you'd add a coefficient. So we move on to step number 3. We're going to balance our oxygens by adding water. Okay, let's take a look over here. We have 2 oxygens on this side, 1 oxygen on this side. So we have to add 1 water because I want to end up with 2 oxygens on the product side. Okay, now we're going to balance our hydrogens by adding H+, my H+ ion. So let's go ahead and take a look. On this side, we have 2 hydrogens. So we have to make sure on our reactant side, we also have 2 hydrogens. We start off with 1. We need 2. So we add 1 H+. Now we have 2 hydrogens on the reactant side, 2 hydrogens on the product side. Cool. Last step, we're going to balance the charge on each side by adding electrons. That's all you could do. You can only add electrons. All right, as you can see here, there's no charge. The charge is 0, but we have a charge of +1. How do I make that neutral, or how do I make that 0? I add 1 electron. And that's it. It's as easy as that. It's kind of fun, actually. So, not very complex. You're just adding hydrogens, H+ ions, and we're adding water. Take a look at here. Chlorine is converted to perchlorate ions in an acidic solution. Again, acidic is telling you to follow those 5 steps. Write the half reaction equation. In this half reaction, is it an oxidation or reduction? We're going to have to see if electrons are being released or if electrons are being absorbed, or and then we can make our decision. So step number 1, we are going to write our equation. So there's our equation. Now take a look over here. Interesting. There's 2 chlorines and 1 chlorine over here. That's going to tell us to do something. So balance all atoms other than oxygen and 0. So here we go. This is the only time you're going to add a coefficient. You're going to make sure that the chlorines are balanced. 2 here, 2 here, good to go. Next step, balance oxygens by adding water in the liquid form. So here we have, because we balanced our chlorines, now we have 8 oxygens The only way we can add another 8 oxygens is we have to add 8 waters. I cannot put a coefficient of 8 anywhere, so I have to say, okay, I have to balance that, I have to add 8 waters. Next step, balance hydrogens by adding H plus ions. So I have to add this in order to balance our hydrogens. Cool, let's do that. Here we go, we have, because there is 8 waters, right? That's what we have to add. We had to add in our previous step to make sure that oxygen's balanced. I have 16 hydrogens. So what do I have to do? I have to actually add 16 H pluses on the product side so that my products equal my reactants. Moving on. Balance the charge on each side by adding electrons. Remember, that's all you can do. You can add electrons. You can't take away electrons. You cannot add protons. You can only add electrons. Keeping that in mind. There are 2 electrons here, okay? Or a charge of 2, I should say. A charge of 2. Here I have a charge of 16 plus. 16 plus a negative 2 is going to give me 14 plus. Cool. This side is neutral. What does neutral mean? It has a charge of 0. So I have to make my products equal my reactants. In order to make my product 0, I have to add 14 electrons. Now, once I add my 14 electrons, I'm a charge of 0 here matches my charge of 0 here. That's it. That's all. Now, we also came to the conclusion that this is oxidation. Why? Because electrons are being released. And they're being released so that it becomes a neutral reaction. That's it, kiddos. It's not that complex. And it's the same 5 steps over and over again, only for acidic reactions. Okay, thank you so much for your time, and good luck.